Hi guys, welcome back to the BME Prep. Today's video we will be focused on material identification. Material identification is important to ensure that whatever materials you may be working with are the appropriate ones that are able to be used in the body with no additional issues, such as a biological attack on the material. This would be of the utmost importance for materials used in things such as drug delivery systems and implants. Identification is also important to ensure that the material you think you are working with is in fact the correct one. The first material identification or characterization tool that can be used in the field of biomedical engineering is mass spectroscopy. Mass spectroscopy is used to determine atomic or molecular masses of materials. The way this process works is by taking a sample of the material and ionizing it in order to expose its electrons. This sample is then forced into a magnetic field in the chamber, and based on the mass of the material, this determines how its deflective pattern emerges from the chamber as shown by the graph. The main materials characterized by this method are natural and synthetic polymers. Another method used is high-performance liquid chromatography, or HPLC. HPLC separates materials based on chemical properties like size or charge, and are mostly used for polymers. HPLC works by using a column that pumps a sample through at high pressure in order to separate the material based on the chemical properties described earlier. A third method used is size exclusion chromatography, or SEC. SEC is a filtration by size concept that involves a mobile and stationary phase. The mobile phase is a liquid solvent that contains the item of interest, and the stationary phase involves porous silica beads that act as a network of pores in order to separate the mobile phase by size. There are two ways in which SEC can occur, and that is through gel filtration chromatography or gel permeation chromatography. Gel filtration chromatography involves an aqueous solvent in the mobile phase with hydrophilic beads in the stationary phase, while gel permeation chromatography involves an organic solvent in the mobile phase and a hydrophobic stationary phase. Both work by a process of eluting or removing of particles based on their size through a column. Normally, the smaller molecules elute last, and the larger molecules elute first, due to their respective weights and sizes. These are the main characterization tools that focus on the size of the materials you may wish to use in products or research projects. I hope you took away the importance of such identification or characterization processes, and I'll see you next week. Bye!